Hi, welcome guys. Yeah, today we're going to talk about TypeScript. There's a lot of interesting stuff to cover, so it will be a demonstration for the most part, but there are some things that we want to mention, like why TypeScript, what is it, and why should we care? So TypeScript is a strongly typed superset of JavaScript, which basically means that it's still JavaScript. It can do just everything that JavaScript does, but on top of everything, we also have these extra features in form of types. So even though JavaScript is a dynamic language, we can get some kind of static typing in it using TypeScript. So why should we care? Let's look at this simple example. So let's say we have some function that takes some object called config, right? And we know that somewhere within nested properties tree there is a URL property that we want to get. And if we start typing config dot in our editor doesn't know what properties this object has, so it cannot help us with the autocomplete. And even worse, even if we make a typo and try to access a property that doesn't exist, then we won't get an error. We will only see this error in the browser. And finally, if we want to know what this config object actually looks like, we need to track it up the call chain to the very top where this object is created, so we could know what properties it has, which means that we're going to spend a lot more time basically working with it. What TypeScript helps us with is that now we can define the type of our variable, and we use this colon syntax followed by the type name, which is config with a capital C. And all of a sudden we get all these nice features, like we get autocomplete in the editor. If we mistype the property name, then we'll get an error in our editor, so we don't have to go to the browser and click through things to eventually get undefined as not a function. And it serves also as sort of documentation, because if we work on this code now, then we leave, then we come back and we want to continue doing something with this function, we can very quickly figure out what the config object is, what properties it has, and stuff like that.
Yeah, sorry for interrupting.
Yeah.
Could you please go to Hangouts and unmute yourself?
Oh, okay. I was thinking the mic would work. Better?
Yeah. Thank you.
So to reiterate why we want to use the TypeScript. First of all, it makes our code more robust, since when we make a typo, we get the error right away. We catch these errors in the editor, not the browser, which saves the development time, as well as saves some nerves for us, because we don't have to worry about our users finding the issues in the browser. The types that we've created will serve as the documentation for our code, so the next person who's working on the code will have better understanding of what our code is doing. It speeds up development because we get the autocomplete functionality, and it also makes refactoring way easier, because when we start renaming properties and this property is properly typed, then TypeScript compiler will tell us right away in which files we need to update this property. And before we start, there is one disclaimer that I wanted to mention, is that TypeScript doesn't guarantee 100% type safety. So since the types we have are sort of imaginary, they're user-defined, and that means if when defining types you make an error and, for example, say that something is a number when it's a string, then TypeScript compiler will believe you, but if the actual value doesn't match the type, everything will break. So we have to be very careful when defining our types. All right, so let's start with a demo. So first of all, I want to show you just a bunch of small snippets just to familiarize ourselves with TypeScript syntax and its capabilities. So as any statically typed language, we have a few primitive types. So in TypeScript, we have a string, a number, a boolean, a null value, which is a separate type, undefined, which is a different type, and there is also a type called void, which is the type returned by a function that doesn't return anything. So basically, the print message function, it doesn't have the return value. So if we hover over it and check the signature, we can see that it's a function that takes a message of type string and returns void. Now, in addition to these primitive types, we also have a special type called any. And any basically means what it says. It can be any type. It can be an object, it can be a number, it can be a string. It can be an object with however deeply nested structure as we want, and TypeScript will never complain about it. And that is the reason why we should try to avoid using any type, because to TypeScript we basically say, yeah, we give up, we don't know what the type is, so you cannot help us. So whenever it's possible, try to avoid using the any type. Okay, so next to the primitive types, we have the object types. So in JavaScript, we definitely need more than just string, numbers, and booleans. So let's see how it works with an object type. So here we have some config object defined with the API prop, which is an object itself with a URL of type string. And if we hover over the variable name, we can see that TypeScript can infer the type of this variable, and it knows basically about its structure. So if down below we start using config object dot end, it immediately tells us that there is an API property and there is a URL property on it. Now, what if we want to separate, like extract the type based on this object? So what we have right now, basically, we already have this type, but it's not usable. So for example, if we want to specify that in this function, config parameter has type of this object, there is no way to do it right now. So what we can do is define a new type called config, and this is the way we define it by saying type config equal. And now we can infer the shape of this object to be our config type. So to do this, we can use type of syntax config object. And now if we hover over config, you can see that it has pretty much the same type, but now it's stored in a type variable. So now we can use it here. And if we start calling something inside the body of the function, we get the autocomplete. So type safety is working. However, quite often we don't want to do it this way. Instead, we want to define type separately and then use TypeScript to make sure that our config object matches the type, and then use this type in other places. So what we would usually do is to define type config with a property API, which is an object with a property URL of type string. And let me just quickly check. Yeah. So now we can specify that this variable is of type config, which doesn't seem to do much, but if while defining this object, we, for example, mistype URL and we typed URI, TypeScript can warn us that there is a typo in here. And as we can expect, the type safety is still working inside of the function body. Now, it's worth mentioning that in TypeScript, there are actually two ways to define types. One is by using type aliases, and this is what we're doing right here. And there is another one by using interfaces. Now, I'm not going to go into discussion how these are different and like when to use one over the other, but basically they're pretty close in their capabilities, and in React applications, type aliases work better than interfaces. So we'll be using just type aliases everywhere. But I'll give you a link to an article in the resources section, just in case you want to read and learn more how are they different. Okay, next I want to talk about casting. And casting is a way to say that one object which is of one type is actually of a different type. So this can be useful in a couple of scenarios. One of them is if we're working with APIs. So let's say we have some data that we got from API. We call the JSON to get the actual object. And right now, the JSON is of type any, because TypeScript obviously doesn't know what kind of data came from an API. But if we, as developers, know the type of data, we can tell TypeScript to interpret the data that we received as a certain type. So here I have a type called API response. So I can say that actually what we get from an API will have this shape. So now if we use this function in some place, then when we get to the data, our data will be fully typed. So again, we know that it has message and status code, which is way better than using any type. Okay, well, sometimes when we define types, we want to have certain properties to be optional. So right now I have a product object of type product, which has a name and an expiration date. But let's say our product can exist without the expiration date. So if I just remove the property from here, I'll get an error saying that expiration date is missing. So to tell TypeScript that this field can be optional, we use a question mark. So now, as you can see, the error went away. We still can use this field. We can pass a value if we want, but now it's optional. And the same syntax is used when we pass arguments to the function. So let's say the function takes two arguments like first name and last name can be optional, and we can specify it by using question mark symbol again. Another useful operator that I want to show is called definitely not null. So let's say we got some div from the DOM by its ID, right? So, and now we want to set its inner HTML. So if I start typing root div dot, TypeScript doesn't give me any options, because at the moment it's not sure what type of data is in this variable. And as you can see, if we hover over it, the type right now is either HTML element or null. And that makes sense because getElement by ID function can return null if the element with this ID doesn't exist. But if we 100% sure that this element is present, then we can tell TypeScript that it's not going to be null by using an exclamation point. So now if I start typing root div, I get all the options that are available to HTML elements. So I can set the inner HTML. Next, I want to talk about generics. So generics is a very powerful concept in all statically typed languages, and it's very powerful in TypeScript as well. So generics allow us to have types within the types, and that means that we can create functions that are more reusable, that can work with different subtypes without using any type, because as we've seen, any type is It's really bad. So let's see. So this is the syntax we use to define a generic type. We use angle brackets, and then we use some letter, which is pretty much arbitrary, but it's common to call it T for type. And once we specified it here, now we know that we can tell TypeScript that the value that will be within this type will be of type T. So how can we work with this? So one way we can do it is by resolving type early, and this is how we do it. So we can say that the box variable that we pass to unbox function is of type boxed, and we can specify, for example, that this is the number. So now if we can call x unbox value 5, the x is going to be the number, right? But if we try to pass a string, it's not going to work because we're expecting a number type. All right, so let's revert this back. But this is not very helpful because even though we have a generic, this function is not really generic because we specify type here. So what we can do is to tell TypeScript that we're going to resolve the type of this type within box type later. And we do this by saying, yes, it's going to be some type T, and we're going to put it also in front of the function. So now TypeScript knows that we'll get some type of T here. We don't really care which one is it. And when we return the box.value, this value will be of type T. So now when we call it like this, it still works and x is a number, but now we can also pass value as a string, and it also works, and now our value is a string. So this is how generics work. One thing I want to mention in addition to this is that we are not limited by using just one type. If we wanted, we can define as many types as we want, and we can have like a second value property, which will be of type D, and then it applies the same here, second value 5. So right now x is a string because we return box.value, but if we return box.second value, it's going to be a number. Okay, next let's talk about utility types. So TypeScript comes with a few utility types that can be pretty useful. So I'll mention just a couple of them to demonstrate here, but I'll encourage you to just Google like utility TypeScript types to know about the others. So here we have some type called article and a test function that takes an article, and then we try to reassign title and the content. Now, in React and Redux as well, we also have to work. We always have to work with immutable data. So actually, we want to make sure that, for example, the value that we passed here doesn't get mutated. So none of these properties should be updated. So one way we can do it is by using a read-only keyword in front of the property. And by doing this, we tell TypeScript that we can read a title of an article, but not write it. And we get an error here as well. But it still works for content. So one way would be to also define it here and here. But if we want to make all of the properties inside of the type read-only, we can use a helper type, which is called read-only. And this is a generic type. And you pass the type that you want the properties of to be read-only, and all of them are going to be read-only. But also please note that this read-only operator is shallow one, so it's going to make all the top level properties as read-only, but if you have something like meta, I don't know, date property, the meta property itself will be read-only, but the date property will not. So in this case, you will have to do this again, say that this one is also read-only. Another helpful utility type is called a return type. And we're actually going to use it a lot when working with Redux. So let's say we have some map state to props function, right, that takes a state and selects some sub value. So this is the type of this function, and I actually have it down below. So it's a function that takes state of type state and returns an object with property colors, which is a string, which is an array of string. Now, if we wanted to extract just the return value of this type, we can use a utility type called return type. So when we do it like this, our map state to props type is now just an object with the property colors, which is an array of strings. Okay, next let's talk about something that is also like very powerful feature of TypeScript, and it's called the type guards. So type guards is a special syntax that allows us to narrow down the type of a variable by using conditional block. So here I have a render text function that takes one argument called text, which can be of type string or of type render function, right? So this is the pipe operator we can use to define union types in TypeScript. Now the render function is defined above, so it's just like a function that returns a string. Now we want to render to the console the text that gets passed to this function, right? But if we do it just like this, if the text that we pass is a render function, then in console we're just going to see like function something like this, right? But not the actual value returned by a function. So what we can do is to use if else block, where we can do the type of guard, and we can do if type of text equal string, and then else so when we do it like this, TypeScript can see that even though the text can be either string or a function, inside of this block, inside of this if statement, it will know that the text is just a string. So if we hover over it, it tells that text is a string. And respectively, since we have only two options, then in the else statement, the text is going to be a render function. So now we can do it properly by using console.log.text here. And if it's a function, then we do console.log text and we call the function. Okay. There are actually multiple ways to do these type guard expressions. One is by using type of operator. Another one is by using a switch case statement. So here I have a complete example where we have a type payload defined as following. It can be either object with this structure or this structure or this structure. And as you can notice, all of the possible variants have a property called kind, and all of them have unique values. And so since all the objects have this property and they are unique, we can use a switch case statement on this field. And by doing that, we'll help TypeScript narrow down on the type. So when the kind is going to be a success, it will know that the response has a property called message of type string. When it's an error, we have a code number, and as you can see, it knows that we have a property called code, which is a number. And for not found, we don't have any payload, but pretty much it already knows that it's just an object with a property kind. And I think that's pretty much it for the basic stuff. If you have any questions, maybe let's talk about them now. Too much? Okay, then I'm going to switch to our project and let's implement some TypeScript features here. So first, I want to show how you can convert your project into TypeScript. And that is very simple. The only thing you need to do is to install TypeScript as a dependency. And then as soon as you rename at least one of your files from JS, you change extension from JS to TS and you start the Yarn server, then it's going to create the TS config file, which contains configuration for TypeScript, and you can tweak some options here. We're not going to touch it today, but pretty much that's all you need to do to get the Create React app working with TypeScript. I mean, if you don't use the boilerplate or use a different boilerplate, then the setup might be different, but with Create React app, it's pretty much done. Now, since we're also going to use types from React library, React Redux library, and a whole bunch of others, we also need to get the types for them. Now, with TypeScript, there are usually two options. Either the package itself contains the typings, or you need to install typings from a separate repository. And you will usually know this whenever you see like import from some library and there is a red squiggly line underneath. It means that the types are missing, and you just install them by, for example, for React, it's called add types/React, and you do the same for all the packages that require types, right? So this is like a centralized TypeScript typings repo, so it's pretty easy to find. Okay, I guess now we can start changing our application to use TypeScript. So first of all, I want to change this theme.js file into theme.ts file. And as you can see, nothing really changed. There are no errors here because the file is pretty simple. But even with this simple change, we can get some really nice type safety. So for example, if we go to our button components and we rename it to TypeScript as well, you can see that here we use like theme.color.gray. And if we made a typo, like so, theme.colors, we get an error right here in the editor. And it tells us, hey, the property doesn't exist, it should be color. So with 0 typings, we already get some helpful type information and type checking from TypeScript compiler. Now, the next thing that I want to do is to create a new file where we can define types for our domain entities, for some models that are used throughout the whole application. And in our case, we have two types. We work with products and we have customers, right? So I already defined these types, and basically I had to look at commerce layer documentation to know which properties we have and what are the types of these properties. So this process is pretty straightforward. Now that we have it here, let's start typing. So the next component I want to take a look at is layout. So I'm going to start by renaming it to TS. And one thing to know is that every time you use JSX syntax within your file, within a TypeScript file, you need to name your files as TSX. So with JavaScript, it's okay to call it just JS instead of JSX, but with TypeScript, you have to be explicit. Okay, so as we can see, we already get some errors. Let's see what we can do about it. So first, all of these properties that we pass to layout are different props. So we can define a type called props. There is a property data test ID that we pass from outside. So I'm going to create data test ID. And since it can be optional, because we only use it for testing, we can mark it as optional. Now, now let's look at the children property. So when we type functional components like we have here, there is a special type that we can import from React package, and it's called FC, which stands for functional component. So we can say that our layout component is a functional component, and this is a generic type with the props of type props. And as you can see, we no longer get an error here, nor do we get an error here, because children is a common type, common property defined inside of the FC type. But we're still missing is authenticated property. And this property gets injected by our connect method. So here we have map state to props function, which takes a state and returns an object with the property is authenticated. So one way to do this would be to just define property like this, and it seems to be working. But a better way to do this is, because if we do it like this and later we rename this property here or remove it, we also need to remember to update it or remove it here. But a better way to do is to use a return type helper that we've seen before, and we pass type of map state to props. And now we can merge the return type of map state to props with the props that we've just defined. So once again, return type is going to return, well, the type of the return value, which is an object with property is authenticated. And then we have data test ID that we define manually. So this is the full props type as TypeScript sees it. So we have everything here, and everything is typed here as well. Now, the only thing missing is the type for the state. So next, let's define type for our global application state. So I'm going to go to the index.ts file in the store folder, and I want to export a type called upState. Now, how can we define it? So here we have a top-level reducer, and if you remember from the Redux lecture, reducer is just a function that returns the next state. So we can use our helper type called return type and pass it the type of reducer. So we're going to get the type of the reducer function and get the return value from it. So now, if we look, if we hover over app state type, we can see that it's a type that has two properties, two top-level properties, cart and customer. And right now it says any because the cart and customer reducers aren't typed, but it's already helpful so that we can go to our layout components. We can import from store a type called upState and we can specify the type over here. And now if here we start typing state dot, we get this autocomplete functionality. Okay, so now our layout component is properly typed. But let's continue with typings for Redux storage. Now, we also have this error here saying that property Redux DevTools doesn't exist on type window. And this is one of the situations where we want to tell TypeScript that we know that it doesn't exist, that we also know that it can exist, because if we have the DevTools extension, this property will be injected. So a simple way to tell TypeScript to ignore this error is by using a comment with a special signature where we start typing it as @ts_ignore. And with this line, TypeScript compiler will ignore the errors on the next line. But in this case, this is exactly what we want. Okay, now let's try to type the customer reducer. I'm going to rename it to reducer.ts. Right. So there is some internal customer state type, and let's talk about it. What is the type of the data that we have inside of a customer reducer? So we can either have a customer object, right, when we are logged in, or we can have a null when we are not logged in. So we can import from common types type called customer type, and say that our customer state can be either customer type or null. Now we can say that the state argument that we receive here will be of type customer state, and the return value of this function is going to be of customer state type. Right, so it's getting better, but we still need to define the type for the action. So let's go to the actions. Okay, so we have, let's see, let's do some quick things first. We have this login init action creator, and we know that username will be a string and password will be a string. Then login success will take a customer, which will be of type customer type. So we're going to import from common types type called customer type, and we'll specify it here. Now then we have login and logout functions, and they have this complex object structure, so we're going to define some types above. So I'm going to create type login payload, which will be an object with property username, string, password, which is a string, and then we have a push method which is a function that takes a path that is a string, and it returns nothing. So now we can use this login payload type over here, right? Yeah, everything is good. And for our logout payload type, we'll just have a push method with the same signature as we have in login payloads. So over here, we'll use logout payload. Now, so what we want to achieve is to have some type that defines an action that will pass in our reducer. Now, this is a little more complicated because the type, let's call it customer action type, it's going to be either a return value, it's going to be of type of return value of login init action creator, or login success action creator, or logout success action creator. So we can use the same return type helper and say type of login init. So now it thinks that the customer action can have this shape, but it can also be this shape, like in login success. So it can be either type of login init or type of login success. And let's finish this up by using type of logout success. So our customer type is pretty big. It has three possible actions, three possible types, which correspond to three possible actions that we have here. And so we want to export it from here because we're going to use it in our reducer. And we'll import it here and specify over here. Now, since we have three different types, we can use the switch case type guard expression as we've seen in the demo a little earlier. But as you can see, it doesn't work because it cannot actually tell the difference between these three types, because when it inferred the type of the actions based on these functions, it decided that the type can be just a string, but we need this type to be a unique value. And even though it's right now it is a unique value, so we use these three constants, which are defined over here. TypeScript still doesn't know about this. So the way to do it, it's a little hacky, but we can use this casting or type assertion operator, and then we pass the value again. So if we look now, for the first action, it knows that the type is the actual string value, not any string. And we need to do it the same for all of our action types. And in newer version of TypeScript, you'll be able to do something like this, to say just sconst, but the newer version has some performance issues, so I'm using a slightly older one, which is like 3.3, and 3.4 already has support for this new syntax. So I'm going to finish this up. And now if we go to our reducer, the error is gone. So it knows that action here will have the payload with the object customer, which will be of type customer type. Okay, that is good. Okay, the last thing that I want to type is the product detail page. So let's quickly finish this up as well. So over here, we already have a few things that we can fix pretty quickly. So let's start by defining a local type called props. Our product view is a functional component with type props. Now we have this add product function that comes from it gets injected by connect method, but it comes from map dispatch to props object. So we can use type of helper and then define map dispatch to props. So now our props know about this add product function. But we also have this match property. And this is the case where you should know where it's coming from, and it's coming from React Router DOM. So what we can do is we can import route component props helper type from React Router DOM. And then we can combine it over here. And route component props is a generic type, and as a generic type we specify the params name that we're going to use. So we're using product ID over here, so it's going to contain a product ID of type string. Yeah, so the error went away, but we're still not done because we're using this use API hook. And right now, if we hover over product type and the data returned from it, it says null, which is not correct, obviously. So first we need to type the use API hook. So I'm going to rename it over here. And let's start with some easy stuff. So resolve condition is a variable that should be an array, and we don't really care about the type of items in the array since we just pass it down to use effect hook. So we can say that this is a read-only array of any type, right? So we don't care about the type. Now the function that we receive here is a function that will call an actual API, and it will return a promise with the type of data that this API returns. So it's going to be a function that takes, actually, we don't know how many arguments it takes, so we can use this spread syntax and to define however many arguments it receives, and it's going to return a promise of some type. Now, we actually want to save the type of the data that we get from an API to make sure that the data that we return from this hook has the proper type. So I'm going to use promise of type T, and so I'm going to put T in front of the function here. Now, we don't really do anything with these arguments that we receive here. So we can, again, use just array of any types. And it's safe to use any when we don't do any particular transformation with this data, because we're just going to pass it down to another function. And the same applies here. So it's going to be an array of any. Now it's almost done, but the set data here returns an error. And this is the problem, because when we used use state null for our data, we basically told TypeScript that the data can only be of type null, which is not correct. In reality, the type of data will be whatever type got returned from an API. So we can specify it over here that the use state function is going to hold type T. So now the data is going to be of type T, and set data accepts data of type T. Which creates another problem that since this type T is always, it's not optional, and there is no way to specify optional generic, then null here doesn't work. So the easiest way I found to fix it is by using definitely not null. So even though what we're saying is that the null value is definitely going to be not null, which doesn't make sense, but it works in this case because we'll set the actual data later. So our use API is now fully typed. Let's go back to the product view component. Now, if we hover over data, now it doesn't say null, but it says any. And the reason for that is because our getProductById function is not typed, and by default, TypeScript only can figure out that it's a promise, but we don't know what will be the type of the data. So let's take a look at this function. So we're going to call some API, and then we use this format product function that should return an actual product. So instead of typing this, we're going to use this helper function, and let me find it over here. Let's rename this to TypeScript. Now, we know that this function is going to return a product type, so we can import from common, types, product type, and we can specify it here. However, we still need to type this data and included types, and I'm just going to paste it from before, but basically what I had to do is go to Commerce Layer API documentation once again and know that the data is going to have these attributes, the included property will have this structure, so now we can say that the data is going to be of type data and included is going to be of type included. Now there is another problem, and that is because the find function can return null again, so we cannot just call attributes on it. But since we know that for our product the included array will contain the value that we're looking for, we can use the exclamation point operator to fix this. So now if we go back to product detail component, we can see that it is finally fully typed and there are no errors. And I think that's pretty much everything that I wanted to show you. So yeah, I know it's like a lot of information, but as soon as you start typing this stuff instead of just looking at me doing it, it's gonna make a lot more sense. And I guess this is a good time to start talking about the homework. So before we get to homework, I have a couple of resources that I've included for you to check out. There is this great TypeScript blog written by Marius Schultz, who is was working on TypeScript compiler itself, so he has great material, very detailed explanation of all the things that you're going to use. Then there is this TypeSync repository I haven't shown you yet today, but this is the library that allows you to install types for all of the libraries that you have in your package.json that don't have types yet. So instead of installing them one by one, you can just run TypeSync and you'll get all the types. Then definitely check out the TypeScript guide on a Redux website. Then there is an article that I mentioned that explains the difference between types and interfaces. And there is another one containing pro tips when it comes to TypeScript. This will be interesting for those of you who already know some basics and who tried it before. So definitely check those out. Yeah, and the homework will be basically to convert everything that we have in our application, all the JavaScript files, into TypeScript and basically type everything. Like you've seen that it's not so difficult, and you definitely shouldn't work with tests. Like it's not required, but if you want, of course, please do try it. And yeah, I think that's the end of it. If you have any questions, let's talk about it.
When you start working on a project, do you start using TypeScript from the beginning, or do you prefer at a certain point of time?
Well, it's usually a good idea to start from the very beginning. If you plan to use TypeScript and if you know it, then yeah, definitely start with it, because otherwise it creates like all this overhead at some point when you decide to refactor, as well as up to this point you basically work without any types, so you don't get any of the benefits. So yeah. Anything else?
So in STRV you are using TypeScript or JavaScript?
Like depends on the project, but recently we move in almost all of our projects to TypeScript because yeah, like the benefits are obvious, and if you just check the common trends in web development, TypeScript is taken over. Like more than half of NPM is written in TypeScript, so it's definitely like people are investing in the language. So yeah, we're trying to do the same. Okay. Yes, if you don't have any questions, this is the end. Thanks so much.